Alright, today we will be solving linear systems by substitution. So far we have solved them by graphing and by elimination, but today is substitution, and the name substitution tells us what we need to do. And our goal, first goal, is to solve for either x or y in one of the equations and then take that information and substitute it into the other to solve. So, looking at these two equations, you want to look for the easiest one to solve for either x or y. When I look at this equation, I would have to either divide by -4 or a +2 to isolate the x or y here. So I'm not going to choose that one. I'm going to choose this one. Solving for either x or y here would be about the same level of difficulty, so I'll just solve for y. So I'm taking this first equation and I'm going to solve for y. So all I would do is take the x over to the other side and I would get y equals -x minus 7. So I'm going to take that information and substitute into the other equation. So I now know that y is the same thing as -x minus 7. So I can take that information and substitute it into the other equation for y. So now I'm going to rewrite this equation right here using that information. So -4x stays the same. That's this -4x. Now, instead of plus 2y, I'm going to substitute -x minus 7 in for y. So -x minus 7 and equals -8. That -8 stayed the same. Now work that out. You will notice we now have only one variable in x, so we can actually solve for that. So work that out. I'll distribute this 2 inside there. So -4x minus 2x minus 14 is equal to -8. So combine these like terms. That would be -6x minus 14 equals -8. Add the 14 to both sides. We're just solving for x at this point. So that would be +6 divide by -6. And finally we have x equals -1. So we have solved for x. We know that the ordered pair of this linear system, the solution for this linear system, is at -1 for the x value. So I know that it's -1 comma whatever the y is. I don't know what the y is. I need to take this information, the fact that x is equal to -1, and substitute that into any of the equations I have and solve for y. So I could plug in a -1 for that x right there, or for that x right there, or even that x right there. That one looks the easiest because y is already by itself, so I'm actually going to use that equation. So y is equal to -x, so instead of -x it's going to be negative of -1 minus 7. I just substituted in a -1 for that x. Be careful with the signs here. You have to do it like this. Put it in parentheses. Distribute that negative in, and I get y equals 1 minus 7, so y equals -6. So that means the solution to that system is -1, -6. It's the ordered pair, -1, -6. These two lines cross at an ordered pair of -1, -6. Alright, now for example 2 here, we have the equation 4x plus 3y equals -6 and -4x plus y equals -2. Again, we're solving these linear systems by substitution. So when looking at these two equations, this one and this one, the easiest one to solve for either x or y, I think, is this one. And it looks like solving for this y will be the easiest. So I'm going to take that, -4x plus y equals -2, and I'm going to solve for this y. All I do is take that -4x term to the other side, and it becomes positive, so y equals +4x minus 2. Done. So that part is done. I now know that y is the same thing as 4x minus 2. So I take that information and I substitute it into this equation right here for that y. So I'm going to do that next. So I'm taking this equation in blue, 4x plus 3 times y is the same thing as 4x minus 2. So I just substituted in 4x minus 2 for that y, and that equals -6. Distribute here and here. So 4x plus 12x minus 6 equals negative 6. Combine these two like terms. 4x plus 12x is 16x. Minus 6 equals negative 6. Just solving for x here. So add the 6. We get 16x equals 0. Divide by 16. And we get x equals 0 divided by 16, so x equals 0. So the ordered pair solution is 0, comma, whatever we find y to be. I know now that the x coordinate has to be 0 where these two lines cross. So I take that 0 and I plug it into the easiest place. It happens to be here. So I solve for y. Y equals 4 times x is 0. I know that from above. Minus 2. So y equals 0 minus 2, so y equals negative 2. That one was fairly quick. So 0, negative 2 is the solution to this linear system. Those two lines cross at the ordered pair, 0, negative 2. All right, now for example 3. So when I look at these two equations, again, we're solving by substitution. I want to find the easiest one to solve for. I can solve for x or y in either equation first. So I'll look for the easiest one. Well, the easiest one is going to be this x. Why? Because its coefficient is 1. All the other coefficients, we have a negative 2 coefficient here, negative 8 coefficient here, 4 coefficient here. That would force you to divide at some point, and you can do it, but it's more difficult. So pick the easiest one. So I'm taking this equation, x plus 4y equals negative 14, and I'm solving for x. So I just take the 4y over to the other side, and I get x equals negative 4y minus 14. So I take that information and I substitute it into the other equation for the x right there. So this equation I'm rewriting this way. Negative 2 times x is the same thing as negative 4y minus 14. That's this. Minus the 8y that's already there. And that equals 28. That's this 28. So now work that out. So distribute. So that gives me 8y plus 28 minus 8y equals 28. Combine the like terms, 8y minus 8y. Those actually cancel each other. So I have 28 equals 28. So notice I have no variable left. The y is gone. The x is gone. No variable left. So I evaluate what is remaining. If it is true, then this is infinite number of solutions. If it's false, it's no solution. Well, this happens to be true. 28 is 28, so I stop there and I say infinite. There are an infinite number of solutions. In other words, these two lines are the exact same. They would lie on top of one another. They produce the same graphs. They produce the same tables. They produce all the same ordered pairs. So they are the exact same line. And if you look at this, look at the pattern, all we're doing, we're taking this line right here, underlined in red, and multiplying all terms by negative 2, and you would end with this equation. If you multiply x times negative 2, you get negative 2x. If you multiply 4y by negative 2, you get negative 8y. If you multiply negative 14 by negative 2, you get positive 28. So they are actually the same line, and we have proven that here. So the answer is an infinite number of solutions, the same lines. Alright, last example for this video. We have 3x plus y equals negative 4 and negative 3x minus y equals 5. So we're solving by substitution. So the first step is to solve for either x or y in either equation. So I'll look for the easiest one. I think solving for this y right here would be the easiest. It has a coefficient of positive 1. This y is it has a coefficient of negative 1 instead of positive 1, so it would still work out, but this one will be the easiest. So I'm going to take that 3x plus y equals negative 4, and I'm going to solve for y. So I take the 3x over to the other side. It becomes negative when I do that, so negative 3x minus 4. So I now know that y is the same thing as negative 3x minus 4. So I take that information and I sub it into that other equation for y right there. So be careful with the signs here. So negative 3x minus, instead of y is the same thing as negative 3x minus 4 equals 5. So be careful, you do have to distribute this negative sign in there. That is an implied negative 1, so the negative 1 will get distributed there. So I'll have negative 3x plus 4 equals 5. Combine my like terms, negative 3x plus 3x, those cancel one another. So I'm left with 4 equals 5. So no variables left. The x and the y are gone. So I evaluate what's left. If it is true, it's an infinite number of solutions. If it is false, it is no solution. This is false. 4 does not equal 5. So the answer here is that there is no solution because these two lines must be parallel with different y-intercepts. They will never cross. So no solution on that one. That's it for this video.